Today we're going to learn the derivative of sine and cosine, and then in class we'll add the rest of the trig functions, tangent, cosecant, secant, cotangent. So let's start out by actually just graphing the derivatives. So I have the graph of sine and cosine here. Remember, sine and cosine are a periodic function with a period of 2 pi, so they repeat every 2 pi. So I have one period graphed here. And so let's graph the derivatives of each of these. So if I'm going to graph the derivative of sine, the places that we have horizontal tangent lines are at pi over 2 and 3 pi over 2. So those are the places that the derivative will be 0. And then the slopes are positive over here. So we're going to have positive slopes. I'm really going to tell you that the slope at 0 is 1. That's not something that you would necessarily know otherwise, but I'll tell you that. So we're going to get something like this. The slopes between pi over 2 and 3 pi over 2 are negative. The biggest slope is at pi. And I'm going to tell you, once again, you wouldn't know that slope is -1. And so, oops, let me graph that a little better. So we get something that looks like this. Y'all, I'm really bad at graphing. And then the slopes between 0 and 2 pi are positive. At 2 pi, the slope turns out to be +1. So we get something like this, okay? If we look at that graph, does that graph look familiar? And when we scroll down, it should look like the graph that we see right below. So this is the derivative of sine that I just graphed. But that function that I just drew looks an awful lot like the graph of cosine. And it indeed turns out that the derivative of sine is cosine. That's fairly nice. We might wonder, is the derivative of cosine sine? Let's see. So if I graph derivatives here, the tangent lines are horizontal at 0, pi, and 2 pi. If I continued this graph, the tangent lines would be horizontal at the 0 and the 2 pi. Okay. And then the slope is negative between 0 and pi, and we have the biggest negative value at pi over 2. I'll tell you that that value is -1, the slope there. So we're going to get something like this. Then the slopes are positive, biggest slope being here. So we get something like this. Okay, that sort of looks like a sine graph, but it's not exactly the same as sine, right? So it's actually sine flipped across the x-axis. So we see that sine goes up and then down, whereas the graph that I just drew goes down and then back up. I didn't draw it very nicely, but if this is sine flipped across the x-axis, then what this is that the y values have changed signs, plus or minus signs. And so the graph that I just drew is negative sine of x, and that is the derivative of cosine. So the derivative of sine is positive cosine, but the derivative of cosine is negative sine. So you have to be careful about that. It's going to turn out that all of the cofunctions, cosine, cosecant, cotangent, have negatives in their derivatives. That's going to be the easy way to remember that. Okay, we'll learn the derivatives of tangent, cotangent, and cosecant in class, and secant as well. Okay, but let's just go ahead and do a few here. So if I have 3 times sine, I just keep the 3 and I take the derivative of sine. So the derivative of sine is cosine. So I'm going to have 3 cosine. I keep the 4. The derivative of cosine is negative sine of x. So we could write this as 3 cosine x minus 4 sine of x. This next one, I have e to the x times sine. That's a product rule that I need to do there. So with the product rule, I take the derivative of e to the x, which is e to the x. I leave the sine alone, then I leave the e to the x alone, and I take the derivative of sine, which is cosine of x. This next one, you should try it on your own. The 4x cubed is just 12x squared. And then this piece, I have a product. I need a product rule there. So the derivative of x squared is 2x. I leave the cosine alone. Then I leave the x squared alone. The derivative of cosine is negative sine. Make sure you put the parentheses around that negative sign, or just go ahead and pull the negative all the way out front here and make it x squared times sine. We want to make sure that that is multiplication between those two pieces. Okay, and on this last one, to find dy over dx, I need the quotient rule. So the quotient rule tells me low times d high, the derivative of 4 sine will be 4 cosine, minus high, 4 sine of x. D low is the derivative of e to the x, which is just e to the x. And then I have all over rho squared, which is e to the x squared. Remember that we don't have to use product rule. Ooh, I'm sorry. We don't have to use product rule on something like 4 sine of x because the 4 is a constant and its derivative is 0. The only time we have to use product rule is when we have like an x times a sine or a cosine. And we'll do lots of practice in class.